All right, so let's take a look at Photoblog, Cookie, and memcache. And there's a really nice README in here. So if you come and take a look at that on GitHub, it actually reads more effectively on GitHub. Or there was.
Refactor nodes.md. Click on it.
Oh, thanks. So these are some of the things that we needed to do. And most importantly is this FYI, this is an unrealistic example. So you need to look through that. And the whole process at the end of this would be, and I'd really like feedback from other experienced Go developers if I'm missing anything here, is that we're going to store a UUID in a cookie, and then we're going to store session info in memcache, and we'll store session info and user info in data store. So there could be additional information about that user in the data store. And then we'll store files in Google Cloud Storage. And so that's all the storage. So cookie, memcache, data store. So let's just, and Google Cloud Storage. So let's just talk about those first 4 points right there. Like, why is that a good way to do it? We talked about this a little bit before break. Doesn't wrap. Anybody have any thoughts on it?
Well, by storing the okay.
So how about this? Why do we use a cookie for this?
For identifying the user.
Okay, so we're going to need cookies because we need to tell who this guy is. So we need the cookies. So why would we use memcache?
Instantaneous, strong/strict. What's the word?
Consistency.
Consistency. Yes.
Strongly consistent.
But we have to be careful with it because memcache is extremely volatile.
Yeah.
So we can only use it to take info from the user and pass it on to the data store, I suppose.
We can use it as basically a duplicate of the data store because the memcache is faster and it's that strong and consistent step. So we can use memcache first, and if the volatility has gotten rid of it for whatever reason, we still have a backup in the data store.
So you kind of have a parallel system going here where you use the memcache to record the changes and save the changes while also passing on those changes to the data store.
So yeah,
and if the
our
memcache
writes will go to
goes
both of
boom,
them.
then we pull all the info from the data store back onto the memcache and then keep on updating through there.
Yes. So yeah, our writes would go to both at once, but our reads, we'll just check the memcache first. If it's not in the memcache, then we can go down to the data store, which is non-volatile, so it will definitely be there. So then Google Cloud Storage, we only kind of briefly touched this, but does anyone remember what that one would be useful for?
I'm guessing long-term memory storage, the history of the site, or...
So Google Cloud Storage is not like Data Store. Data Store is a database. Google Cloud Storage is basically they gave you a folder on a hard drive somewhere. So that's useful for storing just like big files. So I mean, Data Store is a database. It's good for data that you need to look up and into and such. But if you got like a whole picture or something, that doesn't quite fit. That's like that's just a big file, big blob of data. That'd be better placed in the cloud storage.
So all of your.
So in this case, this is a photo blog. So it's you are posting photos to this particular website. So we put the photos themselves in the cloud storage, and then maybe in the data store we might have a list of which photos that who the photos belong to.
Right. What else would we put in the cloud storage besides the photos?
Yeah, not every website uses cloud storage. This website probably only would use the photos. YouTube style website would have all their videos in the cloud storage. If you're like posting books or something, you may want them in cloud storage. But yeah, in general, A lot of websites have no need for cloud storage, which is why they actually require some additional steps in order to turn it on for a particular project.
Yeah, so the main one, you could just think about this as 1, 3, and 4, right? And then memcache is kind of thrown in there, but 2 and 3 work together. So the user ID is in the cookie. That tells us, okay, we can associate that user ID with information on the server. And then the data store is where we're going to store things persistently, but it's not strongly consistent.
And it's also slower.
And it's slower. So we could take that data which we want to access more quickly and also access with strong consistency, and we could also store it in memcache. And then any files we'll store in Google Cloud. And so when we retrieve stuff, that's just the first 4 steps is storing. And then when we retrieve stuff, we'll retrieve from memcache. We'll try to attempt to retrieve from memcache. If we can't get back from memcache, then we'll get the information from the data store. And if we get it from the data store, we'll then put it into memcache. So the next time we come back to retrieve the information, it'll be in memcache if memcache hasn't been flushed. But if it has, we'll get it from the data store again and put it back into memcache, right? And so memory is just memcache is this place where we could just, it's a cache in memory where we could store stuff. And then we'll get our files from Google Cloud Storage. So that's the game plan of what we're going to work towards building. And so I outlined all that right here, the changes that I had to make in the code to get that to work.
So that part's not the unrealistic part that he was talking about. That's actually a pretty good design for.
Yeah. Yeah, that's not the unrealistic part. The unrealistic part here is we're storing right now in the cookie the user ID and the path of pictures, right? Because we're not using data store. So I need to have some sort of persistent storage for the paths to the pictures. And the cookie is going to be that persistent one, not data store. We're not using data store yet. This is just a stepping stone, right? And we're just right now we're doing step 1 and 2, right? And so then I get my cookie back with my UUID, and I'm like, okay, well, let's go get the path of pictures from the memcache. Why? It's already in the cookie, right? That's not realistic, But eventually, we're going to take that path out of the cookie, the path to the pictures out of the cookie, and we'll store that in the data store, and just the UUID will be in the cookie. And then we'll say, okay, is it in memcache? No, okay, grab it from data store. But this step right here, where it's just memcache and cookie, is not a realistic example.
So,
thanks for clarifying that.
So yeah, we eventually want it to be like this list. We don't have that yet.
Yeah. And that's what this all explains right here. So going from this example right here, photoblog cookie with memcache, these are the changes, okay? And one of the things that's important to remember is we are taking our data and we use our data as a model or as a struct in the Go programming, and I just call it model. And so that's right here. Right, so that's what's getting stored in the cookie, is a name, a state, and pictures. Part of what gets stored in the cookie. So we take that struct, we turn it into JSON, then we turn it into base64. And we store that in the cookie, and we're also going to be storing that in memcache, like that. And then when we bring it back out, we go from base64 to JSON back to the model. That's an important thing. So do you guys want to look through the code, or do you want to try to build it yourself and look through it on your own? What do you want to do? Look through the code together?
Sure.
It's kind of convoluted. So one of the functions I changed was making the cookie. So what I thought about, let's see, where is that make cookie? User. There we go. So anytime a cookie is created, right, that seemed like a really good place to me to then also create memcache stuff, right? Because my cookie's being created, and so I guess for me the best place where I started was just looking at main, And so I have my template. I parse my templates. I have my routes. And if I'm serving the images, I have stuff to serve the images. And then listen and serve on 8080. And then I generate a cookie, index, generate a cookie. What's gen cookie do? Request cookie session ID, right? Give me back my cookie. If there is no cookie, well then let's create a cookie, right? So I asked for a cookie from the request that came in. Hey, do you have a cookie associated with it? Oh, we got an error, right? The error is not nil, so there's an error. And then let's create a cookie. So new visitor, create cookie. And so what happens when we do a new visitor? Well, initial model. This is a new visitor, so here's the initial model. The initial model is, here's my model, which is that struct. And it's a name, state, pictures. And I just give them one picture to start out with. And then I go from that model, and I marshal it. So I marshal that model. And when I marshal that model, I turn it into JSON. So when you do JSON marshal, it gives you back a slice of bytes. So I get back my byte slice, return my byte slice. So that got returned to the initial model, right? Byte slice came back, and that gets returned. So we made the model, and then we marshaled it, turned it into JSON. So that's right here. Turned it into JSON. And then I get a UUID. So there's my UUID, unique ID. And I'm going to pass that ID and that marshaled model, MM, into make cookie, which also takes the request. And so what does make cookie do? Make cookie will first just print out the ID. So this is the unique ID given to the person, right? And that hasn't been encoded or anything yet. That's just an ID string. And then I'm going to take my marshaled model and I'm going to turn it into base 64. So what's being turned into base 64 is that struct right here, which was turned into JSON and then turned into base 64. And the reason we did that is because we had that issue with some character. What was the character?
Quotation marks.
Quotation marks, right? And so we wanted to get rid of the quotation marks when we store it in the cookie. So when you do, sorry, I meant retrieve. When you do encode to string base 64, right, gives me back a string. Well, takes a slice of byte. So I gave it a slice of byte, gives me back a string. And now I'm going to send the data to be stored in memcache. I'm going to send the data to be stored in the cookie. So I'm storing it in two places. So here, store memc. What does store memc do? Store, did I go to the same? No, I'm still in user. Store MC is a function I wrote and takes a slice of bytes, the ID and the request. I got to get an app engine new context, which is why I needed the request. And I just do memcache and I create a memcache item. So memcache is the package. Item is a struct defined in the package. Okay. An item takes a key, a value, and other stuff. We can look at that. Item takes a key, a value, and other stuff. We're just specifying what the key and the value are. So the key is going to be the ID. In memcache, I'm storing things by the user's unique ID. So later I can say, hey, give me that, and pass in the user's unique ID. And if there's some value stored there, I'll get it. And the value I'm storing is that slice of bytes. Well, what was it that I passed into that right here? It's a slice of bytes of B64. Kind of crazy, right? Because I went from having a model, which turned into JSON. So initial model turned into JSON. And then we did make cookie. Get the ID, initial model, make cookie. And we turned that initial model, that's the marshaled model, it's JSON, turned it into base 64. And then that needs a slice of bytes. So now I turn it into a slice of bytes with conversion. So when it gets stored in memcache, there's the ID, there's the slice of bytes. That's what memcache wants, is a slice of bytes. And I do memcache set, context, and item. That's it. So I've now set that in memcache. So when I make a cookie, anytime I'm making a cookie, I'm storing it in memcache. And then I'm going to get the code, right? Well, here is to store it in the cookie. I'm going to get my HMAC code right here. So here's the value I want to make sure that the user didn't tamper with. So I get a HMAC code right there. And get code, we've already seen that before. And then HTTP cookie, name, session ID, value, I give it my ID. I'm going to just delimit this string with pipes. I give it the value on the store. It's a string, base 64. And then I give it my HMAC code so I can later verify did they tamper with my base 64 code. Lock down, right? I add these flags, I return the cookie. So anytime I make a cookie, I'm giving back the cookie, but I also stored it in memcache.
So that's the part that was bad. You don't want to store it in two places in the cookie and in memcache. You either want it to be all stored on the client side or all stored on the server side. Not really much point to store it in both. And even then, the client side is probably not a very good place to store it anyway.
Yeah, but just another stepping stone so you can see, okay, hey, I stored stuff in memcache. So next thing is like, how do we get that out? Or where is it coming out? So when somebody uploads a photo, I'm going to be adding paths to the photo, right? And so here's upload photo, which we've already looked at. But one of the things it does is add photo. And it takes the file name that we've created, takes the context, sorry, the cookie, and then also takes the request. So add photo. I'm going to add that photo to both memcache and to the cookie. And there's some code redundancy here. And I've made it redundant, otherwise, you know, you get some issues. I just haven't abstracted it. Yeah. So from my cookie value, I get the excess. I do string split and split my cookie value on pipes. Well, we just saw right here's the cookie value right there, right? And the data is divided by pipes. ID, base 64 encode. ID is the UUID. Base 64 is the data. Code is the HMAC to verify the data hasn't been tampered with. So here, I'm getting string split cookie value on pipes. It gives me back a slice of strings, XS. X is like slice of strings for variable name. And I'm saying, hey, that slice of strings, give me what's in index position 0. What's in index position 0?
The name?
ID, right? So I'm getting back my ID right here. Cool, I got my ID. I'm going to retrieve from memcache, pass in the request and ID, retrieve from memcache, gets the context, memcache get, context, and ID, and stick that into an item. Where have I defined item? Oh, it just
Right there.
just creates it right there. Creates a memcache item in the return. If I look at memcache get, that's from the package and gives me back a pointer to an item. There we go. And an error. I'm ignoring the error. Bad practice in production code, but just to keep
Especially
code.
from memcache, where the error tells you if the memcache is flushed it or not.
Yeah, but here just to keep it lean and readable. And so now I've taken everything from a model, I've turned it into JSON, I've turned it into base 64. So now I got to bring it back from base 64. So base 64 URL encoding, decode that string, right? Well, that was stored as a byte slice item value, so I need to now make that a string, right? Because
I think there's a plain decode in base 64 URL encoding.
really, I looked for that, but I might have missed it. I want base 64.
Yeah, there we go. Decode.
Decode destination slice of bytes. Sweet. Decode. and it gives me back a
Code takes
int
okay,
and an
it
error.
takes a source.
So it doesn't give me back
okay.
the right thing, right? I
Yeah,
want a slice
the
of bytes.
decode wants an already created slice of bytes for it to put everything into. Got it.
Ah, there we go. I'm going to leave it this way.
Easier.
Cool. And so I got back from base 64 into a string, a byte slice. Gave me back a byte slice. Now I need to unmarshal it from JSON. So give me a model and marshal into that model. Im model, if item's not equal to dil, no, yeah, right. Unmarshal model and then return im. So now I got my model back. And I got it back from memcache. And that came from right here, retrieve MC. And I'm going to do pictures for that model, pictures append to that slice, more pictures. And then I'm going to go back and marshal it to JSON. And I'm going to encode it to base 64. And I'm going to store it in memcache. So that's that one again. And then for the cookie, same thing. Write it to the same place. So going from base 64, decode it from base 64 to a slice of bytes, unmarshal it to a string. Now that it's or to a model. Now that it's back to model, we can append to the pictures. Then we're going to marshal it back to JSON, encode it back to base 64, and get the new HMAC code, and then build our cookie again, and then return that. How many people that's like totally overwhelming? How many people you track that? Okay, so here's the example. It's 1 o'clock. Here's the example I want you to do. I want you to I think I'll renumber these. Create that right now.
So for the memcache thing, do you mean with the UID as a key, which is like some random data as a value?
I don't think you'd even need data. I just want to see you create a cookie where UUID is stored, and then you could store that UUID in memcache. And let's do this.
As a
Give UUID is the key. Yeah, you're right. Okay, but you don't need to worry about storing your name in the cookie.
just put an empty string as the value or something, or empty slice of bytes or whatever.
Well, hell, I might as well store your name in the cookie.
Store.
So to create a cookie, cookies, set cookie, name value.
Well, in the cookie, you probably need the UID as a value, because otherwise you can't look it up.
Oh, right. Well, it's
Name could just be whatever, consistent thing.
yeah. I don't think they need their name in the cookie,
No.
so that's just fine. Interesting. They both have value.
I think I shall make it 2 along with that